Okay, the third problem. We can identify, and people again are doing well with identifying this, that the initial velocity is 0, change in position, initial velocity is 0, acceleration 30 meters per second squared, and displacement 60 centimeters. This is an object moving along a ramp of length 60 centimeters and accelerating at 30 centimeters per second from rest. We can write down our 4 equations of motion, and you need to be able to write these down anytime. You just need to know them. As I've said, these 2 are easy to reason out from the definitions, and these 2 you pretty much want to memorize. You don't want to have to rederive these every time you need them. Okay, so we circle all our V naughts. We circle all our A's, none here, 1 here, 1 here, and 1 here. And we circle all our delta S's here, here, and here, and here. 4 of them. Okay. Then we can quickly recognize that neither of the first 2 equations is going to work with this information. And if we tried to reason this out, and we should try to reason this out by pairing up quantities, there's nothing to pair up V naught with. Pairing it up with A doesn't lead to anything. Pairing it up with delta S doesn't work either. Pairing up A and delta S doesn't work, so there's nothing we can pair up to reason this problem out. We are stuck, okay? If there was something we could pair up to reason it out, then one of these equations would work. So the situation then is that we've got this equation or this equation. And in each equation we know 3 things. There are 3 things here, 3 things here. What we don't know in this equation is delta T, which appears here and here, but it's still just one quantity that it turns out we don't know. Down here, the thing we don't know is VF. So which equation are we going to use? We could use this one to find VF. We could use this one to find delta T. Well, it was observed, one of our students saw this, that this is going to be a quadratic equation in delta T because it has both delta T and delta T squared. And I'll simply tell you, you don't want to use that equation to find delta T unless you have no other alternative. That's somewhat confusing, even if you know how to deal with quadratic equations. It's still somewhat confusing. It's confusing how you interpret your results, and you get 2 results that are difficult to interpret. Down here, you're going to get 2 results as well for the final velocity, because when you solve for, if you know what VF squared is, then VF is going to either be plus or minus the square root of whatever that's equal to. But in this case, the interpretation is much more obvious and much easier. So just general advice, don't use this equation to find delta T. If you have the information for this equation, you have the information for this one. And this one is much easier to solve and much easier to understand what the solution is telling you. Okay, so we proceed to do that. And we don't have to solve anything. We don't have to rearrange the equation. It's just all sitting there waiting to be solved. So VF squared, we plug in the V naught squared, plug in the V naught, 0. We plug in the A, 30 centimeters per second squared, and the 60 centimeter delta S. And we have the formula for VF squared. Multiply this out, and conveniently, this comes out 3,600 centimeters squared per second squared. It's convenient because we know that 3,600 is a perfect square of 60. We know that certainly because we know why there are 3,600 seconds in an hour, right? 60 seconds in a minute, 60 minutes in an hour. So, solving VF is going to be plus or minus the square root of this quantity, plus or minus the square root of 3,600 centimeters squared per second squared, plus or minus then 60 centimeters per second. And we're going to choose the plus 60 centimeters per second because it's the only solution that really makes sense here. The ball is starting from rest and rolling down the incline. If we regard this as the positive direction, and since our acceleration is plus 30 centimeters per second squared, that's the only interpretation we can really make. It follows that our final velocity is going to be positive 60 centimeters per second. Now there is another solution which would be negative 60 centimeters per second, and as it turns out, that has an interpretation also. If the object had been started from the bottom of the ramp, rolled to the top and then rolled back down, that could be the situation that we're looking at. And if we did that, if we started the object at the bottom and it rolled to the top, it would have, if you assume that your clock is at 0 here, then it'll be at whatever it is down here. We haven't figured that out, but the average velocity is going to be 30 centimeters per second, so we could easily get then, using an equation or using our reasoning, we could get delta t is 2 seconds. Okay? If your clock reads 2 seconds here, it means it read 0 seconds here. And then when you started the thing, okay, if it read 2 seconds at the end after traveling down, your time is 0 at the top, so that if you started it down here before it got to the top, the time here would be -2 seconds, and the velocity at this point would be in this direction as opposed to this direction, so it would be -60 centimeters per second. So there is an interpretation. However, that's not what I really wanted to discuss here. Just how do we use the fourth equation and how do we interpret that solution? And now let's just very quickly discuss how we would get V bar and delta t. I alluded to it, but I didn't write anything down. Having gotten to plus 60 centimeters per second, we could come back into this equation, and now we know VF, and we could then easily solve for delta t. Okay, we know all these quantities except delta t. Or in here, we could also solve that for, substitute our VF in here and solve for delta t. So we could use the equations to find delta t, but the reasoning is really straightforward now. If we go from 0 to 60 centimeters per second, our average is 30 centimeters per second, and delta t is 2 seconds, and that's a really fairly easy thing to reason out. So you could go either way. You could plug this back into one of these equations and find delta t, or you could just, you have the information to find the average velocity, you know the displacement, so you can easily find delta t that way.